Hola, hi, this is Al Nosdal, your statistics instructor. Let's get to work. In this short video, we will start talking about matrix algebra. I'm sure that all the topics we will discuss here are something that you have seen before, but I want to make sure that they are fresh in your mind, because they will be very useful in our study of linear regression. To be more specific, the topics we will discuss are two matrix operations, addition and multiplication. Okay, so we will begin our discussion with an example / problem. The problem is solving a system of linear equations. Okay, let me write it down for you. It's going to be a simple system of linear equations. We're going to have 3 of them, something like this, nothing fancy. 4b1 plus 3b2 will be the first one, equals 92. That's going to be our first equation. 5b1 plus 2b2 equals 80. That's going to be our second equation. And 8b1 plus 4b2 equals 144. Okay, so a system of 3 linear equations. Okay, so before we try and solve that system of linear equations, I would like to point out something interesting, some interesting features of this particular system of equations. Feature number 1, it has 2 unknown variables, right? b1 and b2. Interesting feature number 2, we have 3 restrictions that these 2 variables must satisfy. So this system has more equations than unknown variables, right? We have 2 unknowns and we have to satisfy 3 restrictions. Okay, so next let's try and remember what a solution is. So a solution is a set of values of the unknown variables, in this case b1 and b2, that satisfy all the restrictions of the system. Okay, remember? Good. Well, now that you remembered what a solution is, let me give you one. Okay? For our example, it's not going to be that hard to find a solution, right? Even if you don't remember how you can find a solution for this system of linear equations, you can easily check whether or not a pair of numbers b1, B2 is a solution for the system. Okay? Checking is going to be easy. So I claim that a solution for our system of equations is B1 equals 8 and B2 equals 20. Let's verify. Okay? So possible solution. I claim that I claim that B1 equals 8 and B2 equals 20 will be a solution. Let's verify. So all we have to do is to substitute these values into each of these equations, and if these three equations are satisfied, then that pair of values, B1 equals 8 and B2 equals 20, well, they happen to be a solution for the system. Make sense? So 4 times 8 plus 3 times 20, 3 times 20, that's 32 plus 60, that equals 92. Nice. So the first equation is satisfied. Let's check the second one. So 5 times 8 plus 2 times 20 equals, that would be 40 plus 40, and that equals 80. Nice. The second equation is satisfied as well. Now 8 times 8 plus 4 times 20, that's going to be 64 plus 80, which happens to be 144. So, as I claimed, that pair of numbers, B1 equals 8 and B2 equals 20, is a solution for the system of linear equations. Make sense? Okay. Now, let's talk about the interpretation of our solution. What does that mean? So now let's give context to that system of linear equations. Imagine that these three equations represent the performance of three supermarkets, each with 2 inputs and 1 output. The input B1 is the number of employees. The second input B2 represents the floor area, okay? And the units, say, will be hundreds of square meters. And the output, let me use Y for the output, represents the sales in thousands of dollars. So if we were to predict their sales from the 2 inputs, we would conclude that the number of employees is positively related to sales, right? So 8 times B1 right? So the more employees, then the higher we expect the output to be, sales, right, in thousands of dollars. And we have a similar interpretation for the floor area too, right, for that second variable B2, right? So the bigger the store, then we would expect to have a higher amount in dollars of sales. Make sense? Okay. Now, the most important difference between this example we just solved, we just explained, is the main difference between this example and the problems that we will encounter in this course, meaning linear regression, is that regression problems do not have an exact solution. We will have to settle for a best solution. Okay, and to find this solution, well, we're going to be using tools from linear algebra, matrix algebra, for instance. Okay, so that's why we're going over these. Okay, something that we're going to see in the future, since I am mentioning that we are going to try and find the best solution, is that when you're trying to find the best solution, you have to introduce a criterion. You have to come up with a measurement to determine which solution is the best, right? Okay. So next, what we would like to do is go over matrix operations, right? And we said at the beginning that one of those operations we're going to be discussing in this short video is matrix addition. Okay? Okay. So, by the way, at this point, I am assuming that you have already downloaded and installed R in your computer. Okay, so if you haven't done it, well, please pause the video right now, install it, and then come back and watch the remaining of this video. Okay, make sense? Okay. So, we would like to add the following matrices. Let me write them down here. So now, as I said, we're moving on. We're going to be discussing matrix addition. So the example that we're going to be discussing is this. The matrix is going to be given reading the elements by columns 2, 4, 6, and 5, right? Then I want another one with 4 as the first element, the one located at the first row and first column, then 6, then 5, and then 2. Great. So, now let me remind you how we carry out this operation when we're dealing with matrices. how do we carry out matrix addition. So it's rather simple, really, if you remember. The only thing that we're going to be doing is adding the corresponding elements in the matrices. So, for instance, in this case, the first element that we have here, the one located in the first row, first column, plus the corresponding element at the same location, right? So it's going to be 2 plus 4, which is going to be 6. We do the same with the other one. 6 plus 5, 11. 4 plus 6, 10. And the last one, 7. Right? Easy. By the way, if you want to subtract two matrices, it's the same thing, right? The only thing is that you're going to have a negative sign here, but the rule is exactly the same. You're going to be subtracting instead of adding corresponding elements of your matrices. Make sense? Okay, so that wasn't too bad, right? Okay, so now that we have recalled how this is done by hand, let's try and do that using R. And that's why I told you, I am assuming at this point that you have already installed R, right? So let's launch R. I already have that guy there. The first step is going to be defining our matrices, right? So I'm going to call the first one matrix A. Okay, so to create a matrix using R, we're going to be using a special command. Special command is matrix. Okay. Now there's another function in R, the C function. That C stands for concatenate. Okay, so we're going to be pasting those elements inside the brackets. So something that I would also like you to keep in mind is that R reads vectors as column vectors. So in this case, since the matrix that I want, if you read it by column, is 2, 4, and then 6, 5, that's the way I provide the information to R. 2, 4, then second column, 6, 5. Okay, so that's the first parameter that you have to provide to this special command matrix. Next, as you recall from your linear algebra course, a matrix is a rectangular arrangement of numbers, and it has two dimensions, the number of rows and the number of columns. So we need 2 rows in this case and 2 columns. Let me type it like that, just like that, okay? Once you press enter, you see what you have produced with that command. Make sense? But I would like to store it, save it in an object. So what we're going to be doing here is assigning this matrix to the object called A. We're going to be using a capital A for that matrix. Okay, now we could just type the name of the object we created, and there it is. Okay, so we have our first matrix. Let's do the same with the second one. So instead of A, I'm going to have B. Instead of 2, here I have a 4. I have a 6. Here I have a 5. And I have a 2. Same dimensions. Let me type B so I can check that I got the matrix that I wanted. Yeah, it is the one that we want. And then if you want the sum of those two matrices, all you have to do is type this, A plus B, and you're done. Make sense? Really simple, right? So once you have defined A and B, the sum is really easy to find using R. Just type A plus B, and that's it. Everything clear? Good. So let's move on. Let's talk about the other operation we wanted to talk about today. Let's talk about matrix multiplication. Okay? Matrix multiplication. Okay, so if you remember a little bit about your course, your linear algebra course, this one is trickier. We have to multiply the values in one row of a matrix by the values in the column of another matrix, and then sum the products. Remember that? Yeah? Okay. So let's try again and you know, do an example. Let's do a different one. Okay? Let me define another matrix here, 2 by 2 matrix, 10, 4, 3, and 5. That's the first one. Then 1 and 6, 2 and 7. So as I said, the idea is first what you do is you multiply the values of one row by the values of the column of the other matrix. Make sense? So here we go. Let's try and do this multiplication by hand first. So for the first element, it would be first row times first column. So that would be 10 times 1 plus 3 times 6. Right? Make sense? Okay. And that would be the same as, you know, 10 plus 18, 28, right? If you want this guy here, the second, well, yeah, the element located on the first row, second column of the product matrix, it would be first row times second column. So it would be something like this: 10 times 2 plus 3 times 7, which happens to be just 41, right? Okay, so you proceed in a similar fashion with the remaining 2 elements of the product matrix, and that's it. Got it? Okay. Now, let's do what we did before with the addition. Let's see how you could carry out this operation using R. The first step will be the same as before. First, you define your matrices and then just carry out the operation. You'll see in a sec that in this case the syntax, we're going to have a different we're going to be using different symbols, not what you would expect to carry out matrix multiplication in R. So again, remember that R reads vectors as column vectors, and we want a first matrix to be 10, 4, and then 3, 5. So I think that's what we want. 2 rows, 2 columns. Let me type the name of that matrix that I just created, and yeah, it is the one that I want. Now we want another one, matrix V. This one is going to be a 1, then a 6, then a 2, finally a 7. I type the name of that object we just created just to double check that it is the one that I want. It is. And finally, if you want to find C, well, the matrix multiplication C times D, it would be C percentage star percentage D. It is, you know, what we hoped it would be. Okay, so remember, it is not going to be that hard, just like it wasn't for the addition. The only thing is, you know, the symbol that we use to carry out that multiplication is, you know, slightly different. The thing is that if you only use the star, what you're going to be doing is just finding the multiplication element-wise between those elements in those matrices, and that is not the way that matrix multiplication is defined, right? So bottom line, what I want you to remember, if you're going to carry out a matrix multiplication using R, you have to use this, the percentage star percentage. Okay, then R will know that, oh, okay, this guy wants me to find the matrix multiplication, not just multiply element wise. Okay. Okay. Now that we have remembered how matrix multiplication is obtained, right, how it works, I would like to make a few comments about matrix multiplication. First one, order matters. Okay, AB, the product AB, is not the same as the product BA in general. Okay, so moreover, sometimes one of these products doesn't exist, because what we need when we're doing this multiplication between matrices is that we need the ingredients, the matrices involved in the multiplication to have the right dimension. Okay? And I'm going to say something about those right dimensions in just a second. But anyway, remember, order matters when you're doing matrix multiplication. Mathematicians would say that matrix multiplication is not commutative. Okay? Order matters. Okay. So, as I was saying, sometimes, right, one of these products, I mean, you could maybe, like in this case, we could find C times D. Well, in some cases, D times C is not going to exist because D matrices maybe don't have the right dimensions. So that's my next comment. Matrices can be multiplied if and only if they are conformable. Remember that fancy word? Well, that is, the number of columns of the pre-multiplication matrix equals the number of rows of the post-multiplication matrix. Keep it in mind, okay? So in this case, the pre-multiplication matrix, C, right, has 2 rows. I'm sorry, has 2 columns, right? So, and the second one, the matrix D, has 2 rows. So since those dimensions match, then we can do it. Otherwise, we wouldn't be able to do it. So let me just write it down like this. C is 2 by 2 matrix, and then the other one, D, is also a 2 by 2 matrix. So these guys here, the number of columns of the pre-multiplication matrix must match the number of rows of the post-multiplication matrix. Make sense? These guys here, these dimensions here, must match. Okay. Now, something else, another comment about matrix multiplication. Matrix multiplication is associative, right? What I mean by that is that A times B times C is the same. Let me write it down. It's going to be easier. A times B. If you carry out that multiplication first, A times B, and then you multiply that result by the matrix C, that's going to be the same as A times the product BC. Make sense? That's what we mean by matrix multiplication is associative. So matrix multiplication is associative. Okay. Well, I think this is a good stopping point. Okay. So let's summarize what we did. We talked about matrix addition and matrix multiplication. Matrix addition is easy, right? To find the sum of two matrices, right? Just add the corresponding elements. Easy. Matrix multiplication, on the other hand, is more complicated. It's trickier. You have to multiply the values in one row of a matrix by the values in the column of another matrix. Then you sum the products. Make sense? Okay. Matrix addition is commutative. Order doesn't matter if you're doing matrix addition. Matrix multiplication, on the other hand, is not. Order matters. Well, that's it for now. Okay. Please take care and work hard. See you next time. Bye.